RHS Pre-Calculus presents Sinusoidal Piloting. Demonstrating a sinusoidal graph with the help of Joe Schmo, a World War II pilot. Joe Schmo, an American fighter pilot in World War II, was attempting to escape a war zone above Britain. Noting his altitude at 2,000 feet, Joe is flying at a steady speed of 150 miles an hour. Suddenly, the plane is struck with an enemy missile. Determined not to lose his bearings, Joe quickly rights himself and pays closer attention. He soon recognizes that he must either dip or rise to avoid a missile every 5 seconds. The distance from his highest altitude and the lowest altitude is 400 feet. Joe recalls his pre-calculus class and recognizes his situation as a sinusoidal graph.
Because Joe is flying at 150 miles per hour, but must avoid a missile in a time interval of seconds, we must convert the miles per hour into miles per second. To do this, we simply divide the distance by 60 2 times, since there are 60 minutes in an hour and 60 seconds in a minute. Since every 5 seconds, Joe must change his path, we must multiply our miles per second by 5, giving us our miles per missile, or half of the period, which is the distance Joe travels laterally by the time he rises and returns to a dipped position. Now we can multiply the miles per missile, half of the period, by 2 to get the whole period, which is 0.417 miles. Using the period, we can find b in the sinusoidal equation by performing the operation 2 pi divided by the period, or 0.417, resulting in 15.080. Knowing the distance from Joe's highest altitude to his lowest altitude is 400, we can determine the amplitude as 200. The amplitude is the distance a sinusoidal graph stretches above and below the vertical shift. As provided by Joe, the elevation is 2,000 feet, and also our vertical shift. This leaves our phase shift, or shift of the graph on the x-axis. Since a shift of 0 or any multiple of 0.417 will result in the same graph, we will leave the phase shift at 0 for simplicity's sake. Note that by shifting the graph a half of a period, 0.208 miles, either direction, the equation would turn out the same, except with cosine replacing sine.
Following this discovery, Joe is able to easily avoid the enemy missile.